Parturition can be defined, simply, as the process of delivery of the fully grown fetus on the completion of the normal gestation or pregnancy period. Technically, it can be described as a physiological event involving a sequential, integrated set of changes within the myometrium, decidua, and uterine cervix, that occur gradually over a period of days to weeks. Biochemical connective tissue changes in the uterine cervix appear to precede uterine contractions and cervical dilation, and all of these events usually occur before rupture of the fetal membranes. Before parturition, the uterus is maintained quiet by the following agents during gestation: progesterone, prostacyclin, relaxin, parathormone-related peptide, nitrous oxide, calcitonin gene-related peptide, adrenomedullin, vasoactive intestinal peptide, and probably more. The activity of the smooth muscles of the uterus or the myometrium during parturition can be divided into 3 phases. These are Phase 1 myometrial activation, Phase 2 stimulatory phase, and Phase 3 involution. In Phase 1 myometrial activation, estrogen acts as euterotropin to activate the myometrium. This results to increased expression of contraction-associated proteins or CAPs, activation of specific ion channels, and increase in connexin 43, which is a molecule involved in the formation of gap junctions, if you can still recall from your general physiology. Here is our discussion question for parturition. Recalling what connexin 43 is, what do you think is its significance in the process of parturition? In Phase 2, the activated or primed uterus is stimulated by uterotonic agonists such as the prostaglandin E2, prostaglandin F2-alpha, and oxytocin. Phase 3 is mediated primarily by oxytocin. Oxytocin is released as a reflex reaction to nipple stimulation by suckling. This means breastfeeding is greatly beneficial for the proper involution of the uterus after parturition. This table shows some of the factors responsible for initiating parturition. These are increase in fetal size, distension of the uterus, and fatty degeneration of placenta and infarcts. As shown, increase in fetal size increases uterine irritability, and also the reversal of progesterone block. Uterine distension, on the other hand, causes reflex contraction because the myometrium is, after all, a smooth muscle. Fatty degeneration of placenta and infarcts causes interference in fetal nutrition and separation process of the fetus from the uterus. This figure shows mechanisms involving fetal cortisol in initiating parturition. As shown here, cortisol inhibits progesterone, which results to loss of inhibition of contraction. Cortisol also stimulates the secretion of oxytocin. Both of these stimulates myometrial contraction, which, in turn, results to the fetus pushing against the cervix. This leads to a vicious cycle since mechanoreceptors in the cervix signals further release of oxytocin. This figure shows the other mechanism involving fetal cortisol, which is secreted as a result of the so-called fetal stress. As shown, fetal cortisol directly causes the secretion of enzymes converting progesterone to estrogen, and an increase in prostaglandin F2-alpha. Estrogen, in turn, stimulates secretions in the female reproductive tract, resulting to an improved lubrication. Estrogen also directly increases myometrial contraction, resulting to an overall increase in pressure or push. On the other hand, prostaglandin F2-alpha also increases myometrial contraction, causes luteolysis, and stimulates secretion of relaxin, which, in turn, causes the pelvic ligament to stretch. To understand lactation, an important stage after parturition in mammals, it is good to understand it in the context of mammary development. The 2 main hormones involved here are prolactin and oxytocin. The physiologic changes are mammogenesis, lactogenesis, and lactation proper, which is also called galactokinesis and galactopoiesis. Let us start with mammogenesis. Mammogenesis has 2 stages. Stage 1 occurs at the onset of puberty when lobule 1 is formed. Type 2 and Type 3 lobules develop in the succeeding estrus or menstrual cycle. No further changes occur until gestation. Stage 2 of mammogenesis occurs during gestation. Alveolar development and maturation of epithelium at this stage is due to progesterone. Lobule 3 develops due to chorionic gonadotropin. Similarly, lactogenesis has two stages. Stage 1 of lactogenesis or secretory initiation occurs during the second half of pregnancy. Progesterone is most influential at this stage, and small amounts of milk may be secreted. Stage 2 and secretory activation starts with copious secretion after parturition. It is characterized by drop in progesterone, and elevated prolactin, cortisol and insulin. This may be affected by retained placenta, diabetes, and others.